Easy to miss.
We missed this. Wow. How could we miss this?
These run all night continuously.
It's a polishing drum?
These before barreling.
The ball in the bottom of the beer.
Right.
Again, it's another colour of Susan Price.
Good. Right. Yep. Yep. And this is a finer one.
I can understand why a layperson might look at this and think it's an O-ring, but it's really not. No, the tooling for this is far more complex than an O-ring.
See, my definition of an O-ring would simply be a belt that's round. You know what I mean?
Yes,
that's what I'm talking about.
Yeah, and in actual fact, in engineering, you can buy O-rings.
Standard parts, you can go to an O-ring supplier. We've got one 3 near here.
Right.
And you can go and buy it.
But that's
ready-made.
Yeah.
Yeah, but that's not what you use.
No. We make our own tooling. Yeah. And the tooling has to be to a factor of 10 more accurate in 2 important areas than the tooling you would use to make an O-ring.
Okay.
First of all, there's 3 factors actually. You've got the internal and external dimensions of the circumference, if you like, of the ring. You've got the section of the ring. If you cut that in half,
Have you got a picture of
the
that?
diameter. Yeah. Well, that's a
cross-section.
That's a Rega drive belt. So
That's a cross-section of it.
Yeah, and you can see you won't find a mismatch with an O-ring. This half might come down here.
Oh, right.
So the 2 halves would be out. That's common because you can't typically make economical tooling accurately.
There and there are the 2 halves.
Yeah, that's got a lid on it.
At this magnification.
Giant magnification.
Yeah, exactly.
So they're made from 2 halves of peak. So
The tool has to open and shut.
Yeah.
Get some way of getting the belt out.
Right.
That's 2 halves.
see, when you talk about this with me, you are making assumptions that you think I would know, that people would know, but they don't know.
Of course,
But now you're saying, when you make an O-ring, you have to do this, but nobody knows that.
Oh, of course. Well, this particular belt I'm holding.
I didn't mean O-ring. I'm sorry. I used the wrong terminology. I meant this thing that you put around.
But we're understanding of that.
Right. Good.
What the difficult thing for us is to explain to people just how much work is going into what looks like an O-ring.
Right, but isn't.
That isn't, no, not at all. And even this material, we've just spent 4 years developing the material, which we're really quite excited about how this is going to transform performance turntables for us.
And will you be able to supply that to your 2 billion people who have Rega turntables to put this on their turntable and improve their performance?
Yeah, I'm sure we can. Yeah,
There's stuff making them right now.
the real purpose for developing this was for some of our new turntables we're developing, the higher performance ones.
Right.
A typical O-ring tool is a square block of steel, right? Maybe this size, and it will be about 30 millimeters thick, and it will have a groove cut into it to make the ring. Yeah, now let's say the ring's that big, the groove will be
Right, I got you. And
like that.
Then you
Okay, that's a semicircle.
Right.
And then there'll be another half that fits on it, and it has locating pins here to locate the 2 halves together.
Right.
You can imagine that, just a small difference between one of those is going to create an offset.
right.
Okay. What they actually do to make it commercially viable is they put another ring in here.
So they can make two different sizes at the same time?
Well, they usually
while
make
they're at
10.
it? 10 different sizes?
Yeah, they put another one in here.
For different purposes?
Yeah.
While they're
These are British standard sizes. You can just phone up. I could get you O-rings tomorrow from our local supplier.
Right.
British. They would be plus or minus 0.003 of an inch on those diameters.
And then they pour. How does whatever this material is?
The rubber is like plasticine. Oh, here, these are standard.
They're O-rings.
These are standard O-ring. Okay.
These are standard.
So how do they?
O-rings.
But I want to go. How do they pour material?
No,
in?
the rubber can either be just put in as a slab. It's like plasticine.
Oh, I got you.
When it's uncured. third, and the other top comes and squashes it out. Or, if you want it a little bit more accurate, they extrude the plasticine into a long, thin string, and they fit it in here and just fudge the end.
And then they then close it down.
And then close it, and then it's heated for about typically 10 minutes, but varying cycles depending on the material and the time and how well you want the cure. Okay. What we do is, and this is what we're doing at the moment, but it's variable. We make a round tool first because the temperature will be more even over the tool.
Okay.
We have a large hole in the middle, which, if we're looking in section at that, it has a tapered location in the middle of the tool, and then the groove is turned, and we make only one on each tool, and the groove is turned at the same time that taper is turned, so that it's exactly centred onto the taper.
Yeah, so the concentricity has to be correct.
Right.
Okay. This is where the NASA tool maker, he's making O-rings for space rockets, which you can imagine. Do you remember the failure of
the temperature was a problem. It wasn't his O-ring.
But it was about the O-rings going too hard at lower temperature.
Right.
He can make O-rings for space. He can't make O-rings for us accurately enough.
Really?
Seriously, I'm really serious. But because he can't, he's up for the challenge.
I see. Now this is a standard O-ring.
This is a standard O-ring out of this kit, and you'll probably see inside this O-ring, you'll see a split line. You'll see the ridge?
Yeah.
Well, mate, hopefully the camera can see that. And that'll be part of a mismatch between the two halves.
I see.
That Roy's explaining how with different tooling we avoid.
I see.
Yeah. And of course that split will give you speed issues for a turntable.
Sure.
Yeah. Okay. So what just one characteristic of the material that's important is its hysteresis, its modulus, if you like, when it's been moulded. This is how it behaves, how it stretches, how it recovers, its hardness, and how consistent that hardness is in the belt. And if you feel this drive belt, if you just gently feel that, okay, you'll feel a characteristic there.
Right. Okay.
So just to show you the subtleties we're working with, this is a new prototype we're working on.
So little.
You feel a difference.
Yes, you can almost actually feel a squishiness as you move it right in where your fingertips are.
It just feels different to you. Yeah,
absolutely.
And these characteristics of the rubber material itself, and these are two different types of rubber altogether.
Right.
One's an EPDM, one's a polychloroprene, but they all have an impact on the turntable's performance.
Everything
particularly
does.
Speed. Yeah.
Everything affects the sound of everything, and everybody who doesn't think that hasn't spent time listening and making comparisons between materials because.
And these are technical changes where we're measuring characteristics of drive belts, and we're using these new systems Rega has for measuring the performance of a turntable. So we can start seeing what effect different materials have on aspects of the turntable's performance. So it's very much technical. It's technically measuring.
Yeah. And now we're going to go downstairs, and you're going to show me something downstairs.
Yeah, sure. This isn't.
Okay, so now we're looking at a turntable
almost as bad as you.
Does not exist yet. This is the Naiad.
Yeah, this doesn't exist. This isn't on to keep it secret. This is on to keep dust off. That's the only reason that's there. And this is an early prototype.
Oh, that's right. Yeah, I did see this.
That's right. Yeah.
Yeah.
So.
And it only hangs on the wall, or it'll have a.
No, it can sit on a suitable, sensible shelf. But as you can see, there's been a lot of work into that particular shelf to support the turntable. Which.
And it's sitting on points.
Yeah, you have three. Typical as with Rega.
Because most of your turntables are pointless.
Thanks, Mike. So
wow, look at that.
Yeah. So you can see elements of Rega, of course.
Of course.
You would expect to.
Yes, I would expect you to abandon everything you've done for the past 4 years.
So even with a Planar 1, for example, you're going to see links here. Three mounting points for the chassis. The basic dimensions of all key parts. The position of the tone arm, the overhang length, as you mentioned yesterday. this distance between the tone arm, the main hub
Yep.
bearing, etc. But
Oft copied.
what we're looking to do is to study the compromises we've made in the past, which kind of we tend to say are Roy's philosophies on turntable design. And then we're looking to see just how far we can improve every one of those compromises whilst keeping them all in mind as a group.
Right.
So you can see for what is going to be, we still don't know how much one costs. We've not totted up the sum.
But you're minimalizing the structure even further.
An interesting thing is if I just lift him off his shelf so you can get a better view.
Wow.
It is.
You pay more for less.
It's a very, very small turntable.
Yeah, wow.
So you would have picked up from Roy, of course, that trying to keep the mass down of the chassis is very important to us. One way you can do that is to make it physically as small as possible.
Yep.
And
Got
that's
some of these
quite
upstairs,
extreme.
you can show them.
Yeah, I'll show you them.
Now, for this material, you're using a ceramic material for that?
Aluminium oxide ceramic. So that's particularly hard.
That's one of the most stiffest materials known to man. That's what's used in atomic accelerators to fire the atoms into the accelerator.
Wow.
But this material is harder again.
Contentiously harder again.
And what is it?
No, it's measurably harder
Zirconium.
in rock walls. It's zirconium.
Zirconium. And it's machining it must be really fun.
It's
There is
very
no-
lengthy.
There is no standard library of measurement techniques for machining zirconium as we speak. It's a suck it and see exercise. Funnily enough, when my younger son did a master's, it was one of the projects he could have undertaken with Rolls-Royce
Wow.
to develop a portfolio of measurement procedures for zirconium.
And the platter is
The platter
of...
is ceramic. So
And is this going to be for a reader?
no. This was just one of an earlier experiments to see if we could develop a servo type.
That's what I
system.
meant, yeah. So that would be a reader for the...
Yes, but we decided that this was just not to the performance level we were after. So we've ended up developing a system which is based on Ashton's measurement system.
Ah. Oh.
So it's very, very accurate. So a Naiad owner will be able to... There'll be quite a large, elaborate power supply, which you may have seen on Ashton's desk.
Yeah.
And
This is a new material.
Silicon.
that's a silicon
Silicon,
driver, which I believe we've improved on silicon. In fact, if you look at this platter, you'll see how much work this prototype's done. This is actually...
But you're still with the felt, huh? Still with the felt. You are
Yeah.
a true believer in what you believe in, and I admire that.
It's not belief, we
It's-
keep trying to find everything.
It's very, very good coupling. Roy
but
can
it's
explain.
a pain in the neck. It's
What's a dust attractor? You know, it's...
Well, it's as a clutch plate, when you've only got gravity to hold the record
Yeah.
to your drive system,
I like that.
it's very, very, very good, very
Yeah.
rigid coupling. And Roy can explain why he thinks natural wool is better than synthetic fibres, etc. That's essentially what it is, if you can imagine, you know. We've got a we've got a hypercar here.
And it's a
really
very thin.
Yep.
Yeah.
In theory, it shouldn't be there. But
Well, why couldn't you-
the record's not flat, the platter's not, you know.
Right, it likes-
needs some sort of
yeah,
coupling.
yeah.
What coupling's better?
Coupling is good. I haven't done it in years. Thank God for editing. So this is...
These tend to be reference turntables in here. So they were turntables that were part of a just before the pre-production run, when the product went in production proper. So this is, if you like, a 001 of an RP10.
Oh.
Now the reason we keep these reference tables is very important, because if at any point in the future anybody in Rega needs to reference a current RP10,
Yeah.
what was the original then?
Mm-hmm.
Although obviously we have engineering drawings and everything you can measure or record, we can take this product, and if absolutely necessary you can even play it against the current one.
Right.
They should be identical, even though a few years may have passed.
Yeah.
This is, for example, the reference You can see this was created the 11th of March 16.
Yep.
So this was the reference table for the current Planar 3. There's one for a 2 here and a 1. So you'd find a reference product for all Rega products.
That's great to have that. That makes a lot of sense.
Yeah, well, you can imagine.
Phil's Revenge written on it.
Sorry, Rewenge.
It's got Phil's Revenge.
Yeah,
Phil's Revenge.
That's reference. That's my poor handwriting.
Oh, it is. Right, sorry, I thought it said Phil's Revenge. That's my poor eyesight.
And you can see someone, even though this product is very much at the end of its life now, someone recently, this week, has been using this reference 6. And they've been using it actually as reference against the new Planar 6.
What's coming?
Yeah, sure. Yeah.
So this is just going to be called a P6?
P6, Planar 6, yeah.
Well, so we've got a scoop here, but is it bigger, or is it just the black looks bigger?
What I'll show you, so I'll show you one thing, because we don't want to give too much away, because it will spoil the surprises for everyone. But obviously you've got to take the tone arm off in your mind. But I will show you very, very quickly the main important difference. Look at these secret drawings. So
You have to be a bit careful with this, Mike, because whatever's here may or may not happen.
Right. Okay. So understand that this is
for you really. But if you can hold that, you're gonna.
I'll hold the camera.
I think maybe you.
Right. You'll get the difference between the two tables straight away. So even though there's a few bits missing. Okay. So that's RP6.
Right.
Planar 6.
Oh, even though there's no arm on it, it's I think it's obviously significantly lighter.
It's in the order of kilos lighter. Yeah.
And it's a foam. And what is that?
That's just a particulate.
It's a completely different material.
This is very much traditional Rega.
Right.
This is the new modern Rega. Yeah.
So this gets it closer to the more
Close to an 8 and a 10 exactly.
Yeah.
Yeah. So a lot of work, about almost 3 years' work to achieve this composite panel.
Wow.
And because we're having to achieve it at approximately 40% the cost.
That's always the hardest thing, right? To take something you developed.
Yeah, sure.
It's less of
Yeah.
a problem to try to get it to it. Yeah.
Exactly. Yeah, exactly that. So.
Wow.
I mean, there's lots of other new things that are coming on the 6 that compared to RP6, but the major performance advantage is that drop-in mass of the chassis.
Yeah,
That'll make it shine. Really looking forward to it. So.
This all on camera? It's okay?
Yeah, sure.
Oh, wow.
So that's the...
It's very aerospace. Wow.
More Formula One than aerospace.
Yeah.
In fact, the original contractor was a major Formula One supplier. And the current one is ex-Lotus.
Yeah, and in fact he still makes racing kit, racing bodies for things like Exige and you know.
This is the
zirconium. So
wow.
this was quite a challenge because if you're in manufacturing or engineering, if you present someone with this as a drawing, this particular part with this hole being what we would call blind, so
right.
There's no way, it's all one piece of material.
Yeah.
You cannot do anything than try and create that as a hole from the top, and to do that very accurately in all its aspects, the depth, the diameter, the concentricity, etc., and then get a perfectly fitting spindle in a material that only diamond will be able to machine very slowly. Of course, the guys we work with said, "Well, you can't do it."
Can't.
No, won't be possible. We can't make it.
But you did it.
Well, what we did was to beg, you know.
Yeah.
But we just said, "Well, look, tell you what, here's some money. Please try. If it goes wrong, we don't want our money back." And about 4 months later, this turned up.
One.
And they were very proud, and so are we.
It wasn't that was an aluminium oxide.
Well, it was actually, yes, and this was a later development using. That's a very, very elaborate vertical bearing housing for a tone-on.
And super light.
Yes, that's titanium.
Oh.
So there's a few £100 there.
Yeah. Wow.
The machining, as you can see, there's a lot of processes there.
Yep. Wow. Well, and this is
the Naiad platter that you saw downstairs.
without the
fingerprints.
Yeah.
If you put Mike's fingerprint on it, that's going to be worth.
Yeah, absolutely. Yeah, quite. Yeah.
But you still might add the encoder on there.
No, we'll be using the accurate glasses.
Oh, that's right. That doesn't need that. That's a whole different
We'll just
thing.
offer, because it's a nicety. We'll offer Ashton's measuring bit, purpose built to fit onto there as an option.
Yeah, and those people will want it. They will want it.
Maybe.
Yes.
We've mentioned how this project, which was terrific fun for me and Roy, and well, we're getting the benefit of listening to them as well now.
Yes.
Like you did last night. You can listen again tonight.
Yeah. Well, now that I know it.
Now that you've recovered from that plane trip, it inspired us. We realised that the things we were developing here, we can put them on cheaper tables.
Yeah.
So, although this brace, I can show you, looks a little like this. So this is a ceramic brace. It's very, very rigid. It has no tenacity, so you can snap it pretty easy.
I won't.
But one little way, which is one of Roy's favourite methods to demonstrate, if you just rest it gently against your tooth, and then with your fingernail, just tap on the end, you'll feel how instantaneous that energy is transferred. Try your fingernail.
Oh.
You get that?
Yeah.
Yeah?
Hello.
So if you try it now, so this is hundreds of pounds to make. This is £1.
Yeah, very different.
Not as good, but still pretty good.
Yeah, still pretty good.
Rigid. So this is what we can do with Planar 3 when we have a lower budget.
Right.
That's phenolic.
And that's what you're using now?
Bakelite.
Yep.
I don't know what.
Phenolic resin. Yeah. It's a laminate of special paper and resins.
And that's what you're using on the 3 now?
Yeah. Yeah. I mean, the history of this is the guy was a Belgian guy in the 1920s, 30s. His name was Bakelit, and he developed these very, very early polymers, resins.
Very cool. That's going to be quite an item. Okay, I think I'm done because my battery is just about, I have a minute to go in the battery, so that was perfect.
There we go.
Thank you.
That's okay.